why would we even want to bother with this anyway? Well, I mean, we're already getting music from our turntables. Why bother? Right?
Yeah.
I think everybody should be. Why should we listen to JR? And some people shouldn't. Seriously. I will openly say so. There are some people who just, look, if you're not interested in the utmost of fidelity in mechanical transcription, then I'm not for you.
Yeah.
Right? You don't need to listen to me. You can use a spherical stylus and whatever settings the manufacturer told you to use and be on your way and listen to music. It's not my interest. My interest is there's a lot more in that groove and I want to get at it.
JR, welcome on to the Audiophile series. We're so lucky and grateful to have you on the show today.
Thank you. I'm happy to be here. This is going to be fun.
It is going to be fun. So we're just setting up with the audience today. We're going to be talking about, the importance of extracting all of that data that's buried inside of those grooves on a record and what it takes to kind of get there. And maybe we'll start out with something. I want to jump to cartridges, and I'm sure that's what a lot of folks are waiting for us to talk about. But I want to start out with something a little bit different. I want to start out with tonearms. I would love to get your thoughts on the significance on tonearm choices from lengths, material, styles, and also, what do you think is required in looking for a tonearm to pair with your turntable to get that optimal playback experience?
Yeah, okay. Well, tonearms are really my passion, more so than cartridges, so you hit a sweet spot. Tonearms are a necessary evil. Because we're playing a spiral. I think the first mechanical transcription medium that was ever created was, I think, on a wire. And I kind of wish that's the way it would have ended up, because we could have made much better tonearms if we had a wire. But wire has other problems. So here we go. So tonearms only serve to greater or lesser degrees to screw up the performance of the cartridge. Full stop. They can never improve on anything. They can only deteriorate the performance. Why? The most important location in the whole turntable system is the location of the pivot point of the cantilever. That location should remain immeasurably still, because that's the point where the information from the groove is read and converted into electrical signal. Now, imagine, why do I say that? Well, imagine if you lowered your stylus to a non-moving record, and then you just put a little blow on your head shell, just a little puff of air. It will cause the head shell to shake about a little bit, right? Mm-hmm. That creates an electrical signal, right? That's obviously an electrical signal that's not in the groove. What we've done is we have, instead of moving the coil former and I'm using an example of a moving coil here, instead of moving a coil former in the magnetic flux field, we moved the flux field relative to the coil former, which was remaining otherwise still. So when we use the stylus to read the content of the groove, and that energy is transmitted via rigid cantilever on up to the coil former, and then the coil former is doing this in a magnetic flux field. We want that coil former to of course, respond with utmost faithfulness to what is happening down to the stylus at the groove. But we don't want the apparatus that surrounds that coil, the magnetic flux field, the cartridge body, the head shell, the tonearm. We do not want that apparatus to respond not one iota to the perturbations in the groove. Because as soon as the cartridge body, the magnetic flux field, the head shell, the tonearm responds to a groove content, that is, by definition, mechanical distortion, which becomes electrical distortion. It becomes part of our noise floor and just obscures all of the opportunity for everything we could have. inner detail that's absolutely striking and amazing. The separation of instruments, large soundstage, fantastic imaging, excellent transient attack. All of that starts to go missing to a greater or lesser degree as you allow that the area surrounding that precious location, the pivot of the cantilever, to move about. So the role of a tone arm is very, very difficult. The perfect tone arm would have infinite mass and infinite rigidity. It wouldn't move, vibrate, or resonate for anything, right? It would only provide an infinitely stable platform for that cantilever's pivot. Obviously, this is impractical. We have to follow a spiral, and we need a vertical moment of freedom, and we need a horizontal moment of freedom in order to track a record. These are inescapable. So how do we do that without offering without offering additional opportunities to destroy the fidelity? Well, you need rigid parts. Number one, rigid parts. And mass is your friend. That's a whole nother conversation. And I'm very much opposed to the common thinking and historical thinking on mass in tone arms. Very much opposed to it, at least at the high end. But that's a whole nother long form video. So maybe we should avoid that one.
Come on, you're teasing us now.
So
I
yeah,
know what you're against.
the devil is in the details too, man. I mean, you could make, for example, you could make all of the parts of your tone arm, let's just say out of diamond, infinitely, I'm not infinitely, but the most rigid item available to us. But if you just make it by stacking plate on plate on plate, well, to make, let's just say, a series of plates that are all, say, bolted together, well, now every time you add two bodies together, whether you screw them together or glue them together, you're reducing rigidity. And you're creating a new mechanical impedance boundary for any vibration that does escape that precious location to bounce right back. Yeah. Right? Anyway, you got to stop me from getting into the weeds, man. I'll keep going on here.
But do double click on that. Is there a specific material that is better if you're looking to buy a tone arm? I mean, does material really matter? Like, what should you look for?
Okay. All right. This is part of the conversation. I probably should have said it earlier, but the part of the conversation where I have to state a disclaimer. Okay. I can give my thoughts on all of these things. I've certainly got some opinions about it. But if you have a piece of equipment that doesn't comply with what I am saying should be the ideal type of component and build design or material, that doesn't mean you're going to get bad sound at all. It doesn't mean that. If you have a tone arm, that arm one is made from wood, that is not ideal. It is neither rigid, okay, nor is it massive in any way, okay? And particularly the rigid part bothers me. And the resonant frequency of all woods, well, there's a reason why we make many instruments from it, is because they resonate at a lower frequency that is more enjoyable to us. And lower frequency resonances are more difficult to damp out than higher frequencies. We see this in acoustics. You can damp out with almost perfect absorption coefficient 1100 hertz signal with 2.5 inches thick of material, but to do the same amount of absorption for 110 hertz, you need 2.5 feet. Right? So it plays out there too. I did a video recently in my Soundbots series. I do a video every week now on a tone arm that violates many fundamental principles of tone arm design. But I talked about why it can sound good and what advantages it actually has. But I want my cake and I want to eat it too. I want all of the design principles that constitute optimal mechanical transcription to be realized in the equipment I'm using. And I'm not interested in making compromises where I don't have to make compromises. Part of a large amount of the work that we do is to understand all of the variables that go into what we hear. And it's shocking how many things matter. One example, raising and lowering the tone arm. People say, oh, I'm going to change the VTA by raising or lowering the tone arm. And they have these things called VTA on the fly mechanisms. I got one on this tone arm. It's a total misnomer. Because yes, indeed, you are changing VTA and SRA, two very, very different things, by the way, which require different targets. I do videos on that too. By raising and lowering the arm, what you hear bears no relationship to what it sounds like when you change SRA and VTA alone. What we're hearing when we raise and lower the arm are the impacts of changing vector forces. Why am I telling you this story? Because we've oversimplified. For those of us who really care about getting the last iota of information from the groove, we've oversimplified the situation. And if we care to hit all of the variables, we have to attack each one independently, which is why at YM Engineering we're using this parametric approach. We identify what are the targets we need to hit. There's 7 in the alignment setup process, and then create the tools and processes to hit each one, and you will hear the difference. All right? I still don't know if I answered your question.
Well, let me introduce myself. G'day, everybody. And I'm obviously as very much into focusing on JR's words here, and I'm nodding my head in the background because I understand some of this stuff, but not at a level that our guest here today does. But it tails me into the next question, JR, and that is, how do we know when these things are wrong? What are the sorts of things? So from a layman's point of view, if we're sitting there with our tone arm and our cartridge alignment, and we're trying to get a sweet spot that sounds right to us, what should we be listening for? When do we know we've got it right or wrong?
Yeah. Okay. All right. So I think what you're asking for, and you tell me if I misunderstood, you're asking for what are some audible cues that would suggest to us that X, Y, or Z parameters are off. Am I right?
Correct. Yeah.
Okay. All right. Unfortunately, there's very few of them that are very reliable, but I will give you a couple. The only reliable ones, in my opinion, have to do with the behavior of the tone arm, not with the setup alignment of the cartridge. You can be perfectly misaligned with the cartridge and it still sounds good. The point is that if those two contact edges that define that fine line contact style is, if they aren't properly oriented in the groove, you just won't get all of the information from the groove. I've done videos on why this is true. Now, okay, let me try to answer your question. And guys, don't let me get away with not answering any of your questions, all right? Because I tend to get sidetracked. Okay. I tell everybody, if your turntable tone arm cartridge is of a decent quality, and by decent, I mean, you spent, God, I don't even know how much you need to spend. But let's just say if your tone arm cartridge turntable costs at least half the price you put into your digital, and it doesn't sound better than your digital, it doesn't give you greater pleasure, something's wrong with your setup. I'll take that principle up to the highest levels of digital.
Yep. Okay.
I don't care. Okay. All right. The two things that suggest to me that the arms settings are messed up is if I hear one of these two things. One, the sound is dull. Dull. It just lacks vibrancy. It lacks vitality. It's almost always the tone arm's fault. It's either the vertical tracking force is too high, or more probably the horizontal torque forces are too high. Okay? That is too much skating force, or not enough or too much anti-skating force. Or thirdly, possibility of high static friction in the arm. The bearing, the vertical axis bearing, which offers a horizontal moment of freedom, is resisting the course of the groove to go across the record. Both of these situations, or all three of these situations, too high VTF, out of control horizontal torque forces, or high static friction, all do the same thing to the cartridge motor damper. It asymmetrically compresses that little tiny donut shape elastomer that is lodged between the coil former and the rear or front pole piece. There's another audible symptom that also points to the exact same problem, and that is sibilance. Mm-hmm. Sibilance and mistracking, particularly over higher frequency passages, a higher amplitude, higher frequency passages, like a hornblatt or the aspirants from a female vocalist's voice. When you hear them kind of break up, almost 90% of the time.
Yeah, we often, I know as laymen's here, we often hear that and we go, we immediately attribute that to anti-skate, and that's all we think about when we think that's an anti-skate issue, and that sibilance we get, that harshness. So this is really interesting.
Yeah. Or the record, right? A lot of folks blame the record. Oh, the pressing's crap, or the mastering's crap, right?
Right. Yeah. Yes. Yeah. And there is you get before you can blame the record, you have to eliminate a lot of other potential culprits. But usually, the one that's really squealing for mercy is that damper. That damper is subject to a 6-to-1 or 7-to-1 lever arm, depending on the length of your cantilever. So for every 1 unit of errant horizontal force against that stylus, you got to multiply it by 6 or 7 on one side of the damper and minus 6 or 7 times on the other side of the damper. So it becomes really asymmetrically compressed very fast. Now, when you do, and that's why Wally Skater is my most important tool. This is the tool that people don't even realize what it sounds like to live with. So many people don't realize what it sounds like to live with a symmetrically compressed damper. So when the damper is asymmetrically compressed, just a bit, not enough to throw off sibilance, not enough to crush all sense of liveliness or dynamics, but somewhere less than that, it still decreases the size of the soundstage, the sense of realism, the sense of relaxed openness, the distance between the separation between instruments. It still will kill those characteristics, and you wouldn't even know it. You won't know it until you correct for it.
So I want to double click on that for a moment, because I have a Wally Skater, and I will tell you, after I used a Wally Skater, I realized that there was a difference in anti-skating from a test record, which I've used for multiple tables for years, right? There was a difference. There was a difference in anti-skating, and I'll spoil the beans here. After using a Wally Skater, it sounded so much better. But what's the difference? Why is there so much difference using a test record, which tends to be the standard that folks use, and the Wally Skater? What's the difference here for those that don't know, JR?
It's a flawed test, full stop.
Can you double click into that?
It never should have been created. I'll tell you why. I'll double click into that. So skating force is a function. There are two elements necessary to create a skating force. One is you need friction at the stylus. And secondly, you need a geometric function called effective moment arm. I'm not going to go into that right now. Now, friction varies depending on the groove velocity. So a loud passage has got greater friction than an unmodulated groove or really quiet music, right? So yes, skating force actually changes depending on how loud the music is. What these test records do is they use test tracks that no responsible recording engineer would ever put into a musical record. And then they ask us to listen for the distortion, adjust the anti-skating so that the distortion we hear is in the center. Well, then you're assured to overdo your anti-skating, for sure. Because this high friction test track is going to require it if you follow their instructions. It's not a test that should have ever been created.
Yeah, and it's not a real world thing either, is it? In the sense that when you get
to put on
when you're putting on a passage of music, recorded on vinyl, it's not like that.
Right.
Not at all. Nope. These test tracks go up to, I think some of them up to plus 16 dB or something. No way.
Yeah.
Nobody's going to create a constant signal. No way. I'm not even sure that peaks will get up to positive 12. Instantaneous peaks. I don't even know if they'll get up to positive 12 dB. 0 dB. I'm not going to go geek on you. I was just going to go down a rabbit hole. No.
Okay, JR. So one of the next things that I think is really important that the novice thinks may well be really important, and that is cartridge alignment on the tone arm. So they're the sorts of things where people go, oh my goodness, it's like, what do I do there? And how do I know I've got it right? And what am I going to be hearing when it's right or wrong? And can you talk to us a little bit about the importance of that and your take on it?
Well, that's the raison d'etre, right? to mispronounce the French, even though I've got a French name. It's about the only word I speak in French. It's my last name. So that's what we make the tools for, and that's what we do the videos, is to help people instruct people how to find their way to the optimal orientation of that tiny little stylus. The content in the groove, the perturbations in the groove wall, if you're looking straight down it's a 45 degree channel. Perturbations in those walls, what we hear when the stylus goes over it and makes the resulting electromechanical signal. The perturbations in the groove wall that we can resolve through speakers or headphones can be measured in the single-digit nanometer range.
Wow.
There are 1 million nanometers in the thickness of your credit card. This is how sensitive this device is, right? Yeah, very sensitive. But few people have ever heard everything that's in there, and that takes you to use a playback stylus that's a facsimile of the cutting stylus, and for it to be optimally oriented. So I would suggest people that if they want to ensure that they are getting the most out of their turntable, watch the videos on our website. All right, we've got lots of them, and we're adding to them every week. On the main video educational page, there's a section on Start Here, so you can get an overview, and then you dive deeper and deeper. But what you can expect when you do optimize your setup is just more of everything, right? More inner detail, better separation of instruments, better transient impact, tighter bass, higher extended and more detailed higher frequencies. Everything becomes more relaxed feeling. It just sounds less like you're listening to a stereo, more like you're just listening to music. And so, there are, when people send me, I've got a lot of clients who've sent me the cartridge for analysis. And maybe we can talk about that later, but I've seen several hundred cartridges in the laboratory now. I don't know of a single, and I love to hear back from everybody. I love to get feedback. I've never heard anybody say, yet, I'm not getting information I didn't get before out of that groove, a new level of excitement. And part of the reason is, why? I'm not doing anything magical, right? I'm certainly not manipulating that cartridge. I'm just analyzing how it needs to be oriented on the head shell. Unfortunately, because of the way cartridges are built today, they are not optimally designed to get the most out of the groove. That's a whole nother conversation. Why?
I was just going to say on that though, there are, and I know this myself, and I think I already know the answer to this sort of sub question, and that is, you can look at two very much identical head shells that come out of the same factory and that are the same model, and they can be vastly different. Is that right?
Yes. Yeah. I was at a client's place just a couple months ago, and he had, I think, maybe 7 different removable head shells, and he wanted me to. I had 7 different cartridges that I'd analyzed for him, and he wanted me to mount them to each head shell. Well, I had to first figure out what's the angular error of each head shell, and they were very different. I mean, if I plot them out on a graph and do a little distribution curve, the difference between the tails on the azimuth angle was more than 1.25 degrees.
Oh,
now,
wow.
a 0.5 degree on azimuth, everybody can hear on a decent stereo. It's a really sensitive parameter, really sensitive, right? So, yeah, I mean, yeah, they're all over the place. So I had to give them instructions. When you install this one, torque clockwise. Right? Because I've oriented it to be optimally situated when you torque clockwise, because you can install the same head shell on some of these designs, not on a Kuzma. Kuzma is very repeatable head shell design. But the bayonet style, you can reinsert it multiple times and get different angular error every time. So,
and when you see that mechanism, you can really pick that. I mean, when you put that bayonet head shell in and then do it up, the first thing I think is, my God, this could and probably will be all over the place.
Yeah, it will. And again, like I said before, it doesn't mean it's going to sound bad if you're not optimally oriented. It's just less of what you could get, right? And so I don't want to berate the situation too hard. Those are mass market. It's a mass market design to make it easy to change cartridges. I get it. It has its place.
Yeah.
For those of us who want to get the maximum that there is to get from the groove, it's maybe not the right choice. Or if it is a choice you're going to make, learn how to work within its constraints, like I did for my client.
Yeah. Makes sense.
I mean, isn't the solution here, though, JR, just to buy the higher end stuff? Wouldn't it have better quality control and more accurate, whether it's a head shell or a cartridge?
Well, not universally. There's a lot of expensive stuff that isn't designed or fabricated very well, unfortunately. That's a tough one. And I'm not quite sure how to answer that. You do not need to spend a ton of money to get fantastic sound from your turntable. You don't. And
well, that's a lovely thought for us mere mortals that are trying to get the best out of our analog playback.
You don't. I've got multiple clients who spent less than $600 on their cartridges, but insist on sending them to me for analysis. By the way, I always love it when customers, they've listened to the cartridge so they already know what it sounds like. And then when they listen to it after analysis and correction, they can then know what they're getting. I've got multiple customers who've got $600 or cheaper dollar cartridges. It's a priority to them. They love that cartridge, but they want to hear everything from it. That's where their priority set is. Fine. You could spend $10,000 on a cartridge and not have that priority, right? About less than a month ago, I analyzed a new on the market $14,000 cartridge with 20.2 degrees of zenith error.
Oh my God!
Now the fabricator, because there's only 3 companies that make stylus cantilever assemblies. The
fabricator
how is that
even
has
possible? I'm sorry to interrupt you, but how the hell is that even possible?
That is crazy.
I know, but it's possible because the companies aren't measuring. That's why.
Yeah.
Okay? That's why. I know they're not, but because I can see it. I can see that they're not. Because they're within, I've seen many of, I've seen, I don't know, well, I've seen several hundred cartridges and most of everything that it's at top end. And if they have a stylus cannel assembly made from this manufacturer versus that manufacturer, I already know, well, that cartridge, because they've chosen that vendor for their stylus cannel lever assembly, is more likely to be wildly out of control than that other one, right? But listen, again, the one with 20.2 degrees of zenith error. And for those who don't know, the zenith error is the degree to which, if you draw a line between the contact point of the left channel part of the stylus and the contact point of the right channel part of the stylus, you draw a line between there, it should be perpendicular to your cantilever. Industry tolerance is plus minus 5 degrees, okay? And that's very audible. I've got over 30 people now who insist that they've used the Wally Zenith to make corrections by ear for a zenith error. Over 30 people now have reported to me that they can hear a half a degree.
Yeah.
Okay.
That surprised me. So what does 20.2 degrees sound like, right?
Well, that's crazy. And then if we're talking about 5 degrees is a factory tolerance, I'm sorry, but guys, pick your game up. If you're selling cartridges for $14,000, you should be. We as consumers should be able to rely on the fact.
I agree.
We've got something that's repeatable.
Right. I agree, but we're not getting it because the cartridge manufacturers aren't measuring it. It's difficult to measure.
Yeah, okay.
This microscope that I used to make that measurement cost more than my car. I had to hire 2 different material scientists to help me understand how to image it. Because how do you measure something that's transparent, that's in the middle of a transparent body?
Yeah.
Not easy. Wasn't easy at all. And then to do so and know what my measurement error is. Measurement error is the degree to which you can be wrong. So plus minus half a degree, plus minus 2 degrees, right? So if I'm telling people who spent money to use my services, I need to be able to know what my measurement error is. Right?
Yeah,
so I've gotten much better with that as my practices and my skills and my approaches has improved. But so 20.2 degrees of error, what does that sound like? Well, that cartridge isn't going to sound horrible. Let's just get this straight, right? It's not going to sound horrible. It's not even going to drive you from the room. It'll still sound like music. But if you heard it with that corrected, because it's a timing error, left channel or right channel is ahead in time than the other channel. Yeah. If you hear it when it's corrected, there is no going back. It is dead obvious to you, right? But there's nothing in the presentation itself doesn't, like you asked me earlier about how to identify if something's out of whack just by listening. And I focused on the cartridge damper. With respect to zenith error, everything just kind of gets fuzzy, right? And you lose a lot. The separation between instruments isn't as convincing. The size and breadth and sense of openness in the soundstage just isn't convincing.
You know what I liken it to in a digital form? It's a bit like jitter in a digital.
Yeah.
So cleaning the jitter up is a similar thing. Yeah. Can I just ask a very quick personal question?
Yeah.
How are you finding Lyra, Etna, for instance, SL, which happens to be something I have on the end of my tonearm for those zenith errors, those manufacturing anomalies?
Okay. Well, I'll answer your question, but first I want to start with something positive. The Lyra Atlas is my favorite cartridge. That's what's on. Well, that's what's on here right now. That's a test cartridge. We're doing some research. I love Lyra design. It's fantastic. Few people have heard how good they really are. Okay. And if I ever hear the criticism, oh, well, they're bright or analytical, I know you haven't heard it optimally. I know it. I've turned multiple never Lyra people into Lyra forever people. With that said, Lyra, just like the other manufacturers, have problems, right? They have these tolerance problems. they aren't inspecting for zenith error. They are hardly alone. Maybe, and I should have asked Leif, but that's Johansson of Audiophile, when I did the recording with him in Munich. Maybe Audiophile and Soundsmith inspect for zenith error. Of course, I'm just picking at one parameter now, right? I'm just picking at one parameter. Yeah. Right. Maybe they do on their very highest end models. But both of those manufacturers choose a stylus cantilever assembly manufacturer that makes styluses that are not Japanese form, they're Swiss form, and those are much easier to image zenith error on than Japanese manufacturer styluses. Okay. Much easier, and much easier to get zenith error right because of the way it's mounted. There's a downside to everything. Those styluses wear faster than a Japanese stylus.
Yep.
Right? So I will take Lyra's stylus, even though it will, statistically speaking, have a higher problems with zenith error than, say, an Audiophile, because I prefer the Japanese stylus. Right? Yeah. I love that longevity. Right? Yeah. So hopefully I answered your question. Look, the Audiophile makes fantastic sounding cartridge. Look, these manufacturers, they're all capable of great designs, but they're all hobbled to greater or lesser degrees to deal with the tolerances that they've been given by their vendors. Imaging these things isn't easy. It's tedious. It takes me a while to do. When I first started doing analyses, it took me 5.5 hours to do one analysis. Wow. Right? Now I've gotten a lot faster and better, more accurate.
I guess practice makes perfect, doesn't it, with everything?
Yeah.
JR, I would assume even if somebody goes through your inspection and gets the printout sheet of all the different calibrations and how to set it up and buy all the tools to get their turntable set up, there's still an enemy in a room, man, and that's vibrations that can still ruin in your experience. So what kind of strategies or techniques do you think people should consider? They put all that effort into calibrating it. What else should they be doing to isolate against that in-room enemy?
Yeah. So I talked about the principle earlier about the most important location in the turntable is that the pivot point of the cantilever, right? And this, and I talked about how one source of perturbation for that location is, of course, the groove content. We don't want the groove content to modulate the position of that pivot point, which means the head shell, the tone arm, right? But obviously, you can modulate the position, that same position, by allowing mechanical noise to enter the turntable system from the environment, right? So, and I did a video on this recently. I don't think that one's been released yet, on the importance of isolating your turntable mechanically from the environment. Now, mechanical isolation of your turntable doesn't mean anything rigid. Okay, so spikes, big myth. Spikes don't isolate. Mm-hmm. Any type of spike or any type of rigid footer. Okay?
Shane was saying the same one day.
Oh, you're preaching to the choir, my friend.
Yeah. They do not isolate. But then you ask, well, why do I hear a difference? Why? I have no doubt you hear a difference. Because it changes the mechanical impedance between the payload and the support system. That's it. Right?
It's still a two-way highway.
It's a two-way highway, no doubt about it. No doubt about it. Now, you can have a rigid footer. There are rigid footers that have damping properties inside of them, and those damping properties help filter out higher frequency vibrations. But with a turntable, we're more concerned with low frequency vibrations. So for that, you'll need something like this. I love these. These are made by AV Room Service. These EVPs, or you need this is active isolation, size me on, or minus K. I've got that as well in the laboratory. That's how you help avoid having mechanical noise, which is everywhere, and your worst offender of creating noise for your turntable is your subwoofers and your speakers, which is also why you should put EVPs or something like that. My EVPs are my favorite, underneath subwoofers and speakers. Full stop. Right.
Yeah, I've been banging on about mechanical isolation in componentry and in subwoofers, and I have a Watchdog, Wilson Watchdog subwoofer in my room, and I have the Stack Audio top of the range speaker isolation underneath those.
Excellent.
And immediately when that was done, you could hear everything became better.
Yeah, I have no doubt. And I'm sorry, I'm not familiar with the Stack Audio, but so I don't want to play favorites
similar as the EBPs. It's very much a similar process. They use particle dampening technology in the top, and certainly they do a two-way thing with their speaker isolation. They also spike the footer as well as the particle dampening, so they stop the micro movement of the front baffle, which smears soundstage and image. Definition, and also mechanically through particle dampening technology, decouple it from the floor as best as possible in a gravity environment that we all live in.
Yeah, wonderful. And some people think, I thought for some time myself that, well, if I've got, if my listening room is on concrete on grade, right? Concrete meaning concrete slab on earth. Yep. Oh, well, that, it's massive, it's rigid, it's not going where there will be no benefit. Wrong.
Correct.
I've heard it too many times. And you think about it, here's why that's true. You still have audible benefits from isolating your speakers and your subwoofers by means of compliant means like the items we're talking about. Because that massive slab of concrete, it's very rigid. And what do rigid items do? They transfer energy very fast.
Correct.
And they'll transfer the energy to the walls, and those are timber frame and gypsum and the ceiling. So look, maybe the floor isn't going to be too noticeable, but it'll send its energy straight to where it can dissipate much faster. Right?
The biggest issue we've got is gravity, which we all live in, and you've got an object, no matter what it is, it's a mass, and a mass can be excited, and a mass will then transfer its energy to something that is more excitable, which is, as you rightly say, walls, roofs, all that kind of stuff. And then we start picking all that up in our very sensitive audio equipment, don't we?
That's right. And when it comes to mechanical transcription, turntables, my favorite formula is force equals mass times acceleration, Newton, right? So we don't want any force to be imparted to that precious location, right? No force. How do we do that? By having all the structures around it be rigid. Rigid is not part of that equation, but we have to include that. Massive, all right, rigid and massive, and but the devil's in the details.
Absolutely.
Because like you could have an enormous platter, let's say, that's 600 pounds, and it's just this one enormous rotating cylinder. Well, there's new problems that are generated from that, in that using the idea of stored energy isn't the right way to articulate it, but it's a large item, very large. It will start acting more like a bell, let's say. I don't think I can get away with talking about this in a short form. So
I hear what you're saying. I absolutely hear that, and it's the same thing. I'd love to touch on this with you in a later date, or even on another video when we're talking about room acoustics and room setup and things like that. Something I'm very passionate about. So when we talk about a small room, for instance, it has its issues in the near field, but they're easier, I believe, to remedy than when we start talking about a big room. And then with a big room comes another set of problems. And the same thing applies in this instance with turntable isolation and things like that. That everything is a degree of compromise to get to that sweet spot that we want to reach, isn't it? Really?
Yeah, and again, the devil's in the details. And further to your question about avoiding mechanical vibrations into our sensitive system. And I did a video on this too. What about putting compliant materials between the cartridge and the head shell, right? Because there are some products out there that do that, right? Very compliant materials to decouple the cartridge from the head shell. And a number of people saying, gosh, it sounds better this way. To which I say, I believe you. I believe in your situation, it does sound better. But as I talk about in my video, what we've just done is we traded one bad thing for another bad thing. Yes, we got a net gain, but you didn't treat the main problem. The reason why it was a net gain in your situation is because you're allowing too much mechanical energy to get through to the turntable in the first place. So you choose to stop it at the head shell cartridge union, which causes the additional problems of not being able to allow that precious location to be immeasurably still. It's constantly going to be wiggling about, constantly, which might give you a sense of ethereal, that's one thing, right?
Yep, so presence in the presentation,
So there's a number of linear tracker tonearms that have, especially the air-bearing ones. The air-bearing tonearms, for the most, all of them to a greater or lesser degree, allow 6 degrees of freedom very easily. Within a few microns, they're wonderfully compliant. Well, the net result of that is, and I can't prove this, I'm just going on because we haven't studied this deeply enough, and nor do I have plans to right now, but when you allow a loosey-goosey environment for your precious location, then you can create this ethereal type soundstage, right? But you'll notice you can't get something for nothing in mechanical transcription. It's not possible, right? If you're going to introduce a new problem that gives you something that you like, what have you lost? And unfortunately, with audiophilia, it's tougher to identify those things that don't exist, right? The errors of omission are much more difficult to identify than the errors of commission.
Yeah, look, I agree. This is such a shifting sands topic, and it's very, very interesting. And I know our audience are going to love to hear your take on this, JR, because really it is a series of compromises, and one thing fixes something, which then creates another issue, and I guess it goes into digital manipulation in the digital form as well, with the DSP and room correction and stuff like that. We if we can do without it because we can find something that is convincing in the presentation, we're much better there, I think. But I mean, that's a whole nother topic.
Yes. Yeah, and digital has its place. There's no two ways about it. And it certainly has its advantages. Convenience being one, and discovery of new music. But you listen very differently. I have a very good friend who lives just a few miles from me. He's also an audiophile. He's only in digital, and he spent a lot of money on that system, top end, everything. And I recently delivered him a turntable. Nice. I gave him Kuzma Stabi, same as you, right?
Nice.
With a 4-point, and Hanu Umami Red. And he already had a very nice transimpedance phono stage. And played the first track, and he said, that's the first time I've ever gotten goosebumps while I listened.
Wow.
He said, in this room, I've never had goosebumps like that.
Wow.
And this turntable is not even isolated, right? The cheap interconnect, 20 feet of cheap interconnect going from you. It's not like he's all Dragon interconnect, top of the line audio.
Yeah, right. Yeah.
And so he's listened to music differently. And I said, I listened to the whole album now. That I'm listening differently. And yes, when you listen to vinyl, it demands a different sort of listening.
Yeah. But it's for me, and coming from that old school way of doing things, it's about as close of a capture to what I hear in a tracking room when I'm tracking a recording, or when I'm at a live performance and I'm listening to a live performance that isn't amplified. There is that presence in the position of the instruments. There is the resonance of the timbre in the instruments. There is the breath across the vocal cord for the singer. Those things we hear. We have a heck of a hard time being able to, even today, with all the money we can spend on reproduction, actually really finding that same presence that we get. We're not there. I don't know if we'll ever get there, but to that same level of presently being in the room with artists. But I think we, as close as we do get to it, is in the vinyl medium.
Well, there's no two ways about it. Digital is getting better, and it's going to continue to get better. But part of what going about at the top of my voice trying to say is that there's so many opportunities for vinyl to get better.
Yeah.
And as we've done our research into how to optimize playback, we've had to study how records are cut. So we spent time with people like Kevin Gray and Greg Ryerson and Jim McNair and Helmut Erler in Berlin and J.I. Agnew in Greece. And the opportunity to clean things up at the time of the cut is just as great as the opportunity at playback. The engineers aren't being given the tools that I think they should have in order to cut more optimally.
Yeah.
So I see opportunity there.
Given the resurgence of vinyl, which thank goodness for that, we're back in the process of striving for improvement again, and we're not just stagnant with it. Oh well, it's an old medium, and it's not. We're all talking about it again. We're all buying records again. I mean, Louis is a perfect example of that's right in his wheelhouse, and he can talk about that too. But that's exciting for the industry, I think, and for people like you, JR, and striving to get the best out of that playback, and that it's all back on the boil again, which I think is fantastic.
Yeah, thanks.
Well, it sounds like we have definitely a lot of conversation still left on the table, JR. Perhaps if you would entertain us maybe to come back on a future episode to dive into some of these things, because I feel like there's so many more topics we can get into, especially around room acoustics and treating for those. It's been a pleasure to have you on, JR.
Yep, happy to come back. Happy to be here, fellas.
Yeah, it's been an absolute joy for me too, mate. I must admit, this is a beautiful friendship about to blossom, I feel, and I'm very, very happy to have been able to meet you now and on our Audiophile series, and I've got some questions off camera for you as well.
You got it. No, it was a pleasure, guys. Thank you very much for this time. I love talking about this stuff. I really like the educational component of this. That's why I do all these videos. And look, I've been wrong before. I'm sure some of the things I say right now need correction. I know some areas where I don't know what the answer is. There are plenty of those. SRA is one of them. Never been properly studied, ever. But, I've got a team of great engineers on my side who are interested, as I am, in getting to the bottom of these things and improving our understanding and improving how we can get the most out of our system. So yeah, stay tuned. I'm glad people are interested because it really fuels me to keep it going.
You know what? I have to just jump in very quickly before I'll hand over to Louis to wrap this up. But the whole idea of this series is about educating people that know, that want to know more. And having guests on like yourself, JR, is a great educational tool for our audience. It is a reference that will be on YouTube. People can go back to this and look at it, and I think that's wonderful. We very much thank you for that, and we're very excited to have a chat again further and pick your brain on other topics.
Yeah, and I encourage leave comments, right? Leave comments, maybe leave some questions for JR. So if we do have the opportunity to have you back on, JR, we can maybe address some of the viewers' questions that they have. So if that's all right.
Yeah, I'll respond. Yes.
There you go. You'll respond directly. That's fantastic.
Another thing I think we should do too, while we're here and talking about this, is we should leave a link to JR's educational videos at the bottom of this video. I think that would be very, very good, because we can't touch on everything here. JR's done the work over on his channel, so we should leave a link for that, just for our audience to be able to get in there and really, really get amongst it all.
Absolutely. You stole my thunder, Shane. I was going to say I was going to leave all the links for WallyTools.com, Wham Engineering, and the instructional video in the description. Thank you guys so much for tuning in to the Audiophile series. We look forward to seeing you on the next episode.